All right, welcome to yet another episode 80 of TGI Kubernetes. I'm Joe Beda, and I'll be your host for today. For those who don't know, TGI Kubernetes or TGIK is a weekly-ish YouTube live stream that we do where I or one of the other folks at the VMware team here take a new technology, take something that's interesting or happening in the Kubernetes world, and play with it live. Oftentimes, I don't actually know what I'm talking about, or at least I don't know the thing that I'm presenting super well. And so it's a good chance for us all to learn together as we go through this stuff. So let me just start out by saying hello to everybody that's joining me. A lot of times folks will say hi on the chat here. So we have Lamati saying hi, who's always a regular. Muragesh, nice to see you from Bangalore. Tim from Frankfurt. Shahar says, hello, fellow YAML architects. I'm so torn about the YAML thing. Joe's from London. Good to see you. So the way that we usually set this up is that I'll spend the first 10-15 minutes going into what's new around the Kubernetes ecosystem, what's sort of the news of the week. And then after that, I'll do a deep dive into a specific topic. The project that we're looking at this week is called Velero, and I'll give a little bit about the history and the purpose of that, but real quick, it's a backup disaster recovery system for Kubernetes, so some exciting stuff going on there. All right, so the first thing is that, let me go ahead and switch to my screen, is that, yes, we have a markdown document at this site called HackMD that helps if folks want to sort of crowdsource some notes. And so if there's something interesting that I say, or if there's like some subtlety, if y'all want to help out, that'd be great to actually help out on this. I put all the links that I'm going to be doing as we start out up here. And then if nobody else does it after the episode, I try and actually pull out some time codes and put them in there in the table of contents so it's easier to find stuff in the episode. So yeah, that link is in the chat, so feel free to give that a try. Oh, have I shared it? I've shared it, right? Yes. Okay, so folks that are signed in can go ahead and start playing around there. Let me say hi to some more folks. We have Kenneth from Delaware, M&A from Strasbourg, Istayak from Bangladesh. I just love that everybody is all over the place. It's awesome. Reinhard from Germany. Nolan, who's on the Velero team, and Steve is also on the Velero team. Steve's in Boise. Nolan, I don't even know where you live, man. Oh, Indiana. I knew that, but I didn't know that. Saeed, Eric, Saeed from London, Eric from Belgium, Mahmoud from New York. New video quality is great. Really? Okay. Was it bad before? I hope not. But always trying to improve this stuff. Martin from the Netherlands, Matt from Madison. Awesome. Yeah, and I like, and also, huge shout out to those who are calling in from all over the place. 1 p.m. Pacific time seems like a great time to do something like this, but it's like either middle of the night or weekend in the rest of the world. So it's maybe not the best time. Live and learn on this stuff. All right, let me go ahead and get started. I'm going to jump right in. So the big news this week is Kubernetes 1.15 was released. There's a blog post on the Kubernetes blog. Our very own George helped to pull together all the stuff for the blog post. And I want to hit some of the highlights real quick here. I mean, obviously you can go through this. You can go through the release notes, which is also a huge another big task of that we do when we pull together these releases. Big stuff that we're actually seeing here. So there's a lot of work going on in the part of the project that we call API machinery, which is essentially the core sort of API work and storage work in Kubernetes. Kubernetes at its core, and I'm happy to give a little bit more into this at some point. But Kubernetes at its core is a database with an API sort of layer wrapped around it, and so we're continuing, and I should say we as in the project is continuing to enhance what that API layer does. A lot of these things are around custom resource definitions. And so that's ways that you can extend the built-in objects in Kubernetes, add new objects. And so we're continuing to do interesting stuff there. I'll go down to one of the biggest problems that we have with CRDs, custom resource definitions, is being able to version these things and upgrade. So now there's a webhook conversion so that you can actually start doing version upgrades. How do you get schema information and react to that dynamically? A lot of work going on around that. Do we store fields that weren't originally part of the schema? So a lot of defaulting, like if you write something and you don't include a field, is there a default value for that field? Does that get recorded? All sorts of really, really interesting stuff going on here. Another area where the VMware folks specifically have been putting a lot of time is SIG cluster lifecycle. The big project in SIG cluster lifecycle is kubeadm or kubeadmin. It's essentially a part of the bootstrapping process for getting a cluster up and running. If you have a bunch of machines, kubeadmin makes it really easy to get Kubernetes up and running once you have a bunch of machines. And it's both a full experience with kubeadmin init and join, but also a toolbox that lets you do a bunch of other stuff. And so the HA capabilities of kubeadmin are getting easier and more stable. So that's actually really cool. And there's also some new capabilities around certificate rotation, which is really cool. The thing I'm most excited about is that kubeadmin now actually has a logo, which is an atom. kubeadmin. And so that's super cool. So I want to laser cut this at some point soon. Lamati says, anyone seen Joe? I refreshed the page. Oh no, are you not getting a stream, Lamati? So other folks are seeing a stream. Okay, so hopefully it's something that you can actually get to. Okay. So yeah. So as long as I'm looking, they have Antoine from Paris, Mahmoud saying hi to the Velero team. Yeah. So good to see y'all. All right. So yeah, kubeadmin, CSI, which is the container storage interface, is continuing to move forward. One of the things that's interesting out of this is that, again, there's migration from to actually make this stuff be more and more pluggable over time. And so in-tree storage plugin. So what is this? I haven't actually seen this one. So being able to actually have some stuff in tree. I don't know. I'm gonna have to look into that. What does it mean by in-tree there? But okay, I know a lot of work's been going on there, and one of the big things coming out of that is the ability to clone volumes, and that's starting to treat volumes and actually surface more of the sort of cloud capabilities in a Kubernetes way. Yeah. So the delay in the chat, I'm now using this ultra low latency setting in YouTube, and I hadn't used that before because it used to be that when you enabled that, you weren't able to actually DVR and actually rewind and fast forward and stuff. But now you can actually DVR and do the ultra low latency. So that's actually really cool. So they're definitely improving that. All right. So first of all, I just want to say getting a Kubernetes release out is a huge effort. There's I think the number here is 38 people that actually all get together to make this happen. I want to say it's a well-oiled machine, but I think there's places where we could still apply some oil. But it's a lot of work, and a huge shout out to the team there. And it was Claire Lawrence, who's at Pivotal, was the release lead this time. And so it's always interesting seeing seeing the team come together to get a release out like that. All right, and so there's some other notes in here around sort of volume cloning and alpha, future of CRDs. There's a blog post on that. And then there's a set of things that are being deprecated. And so it's always worthwhile to actually go through some of this stuff and actually see if any of this stuff is actually going to hit you and bite you in the butt. A lot of these things is just changing some naming and how we actually sort of address certain types of resources. So that's worth digging into. So those are in the notes there. Okay. So the next thing that I think is really interesting is HA Proxy hit 2.0, which is a big milestone. And I think really interesting thing here, and I think this is fascinating, is that there is a Kubernetes ingress controller that is part of the HA Proxy project, hosted at the HA Proxy GitHub org with documentation next to everything else. That is super, super, super cool. I love seeing, projects like HA Proxy, really embrace adapting and to Kubernetes, making that be a first-class part of their experience. And I think, this is one of those things that I think is interesting from an ecosystem point of view. It's like, our operator is going to be something like, which is so ingress is kind of a little bit of an operator type of thing. Our operator is going to be this thing that exists outside of the projects, or are they going to be co-developed with the projects, or over time are they going to actually be built into the projects themselves? And so it's fascinating to see projects like HA Proxy really bring Kubernetes support to be a first-class thing. Very, very cool. Is HA Proxy still? A lot of people use HA Proxy. There's a lot of people still using it. Saeed. All right, so this was, George found this one. This is, I think this was as of yesterday. This is a really interesting write-up around how this particular person, this is Bjorn here, who's in, I don't know where Bjorn is, working for Schenker. So I'm going to guess, based on name and then maybe he's in Germany. Talking about how he set up his sort of CI/CD pipeline, or at least the start of it. And I think this is awesome because it's in excruciating detail. Not everybody is going to make the same choices with something like this, but I think seeing something like this come all together and have somebody document it gives folks, I think, a lot of ideas about how they can actually set some of this stuff up themselves if they really want to dig into that level of support. Let's see. Yeah. Oh, so, and George is saying that if folks do want to get involved in the release team, there's always looking for help. And a lot of this is coding. A lot of it is helping to sort through features and requests. There's a lot of process type of stuff, pulling together release notes. A lot of interesting stuff going on there. All right. So here's another blog article. This one's from Daniel Weibel, I want to say, going into a lot of really cool sort of like optimizing your kube control game. Everything from command completion to using kube control to look up formats, custom outputs, switching between clusters and namespaces. What does he use? Does he use Kubernetes? He talks about how these things work. And then my guess is, I wonder if kube context is a tool that actually makes switching this stuff a lot easier. We should have built this into kube control. We probably should build it into kube control. So that's kind of cool. And so a lot of really cool tips and tricks going on here, which is pretty cool. And then they're like talking about plugins, and we're starting to see the crew project for being able to search and install plugins is pretty cool too. Should probably do it. That would be fun to actually do an episode on that. Maybe write a plugin. All right. Next thing is Bonsai Cloud. I think this is is that the right link for that? Yeah, okay, that's just the GitHub thing. This is essentially a toolkit for managing Vault with Kubernetes. So it looks like there's a lot of really cool stuff here. I haven't actually played with this, but Vault sort of has its own way of doing things, and having a toolkit to sort of bridge the gap between Kubernetes and Vault is pretty darn cool. And so this is the Bonsai Cloud folks putting this together. And then the last thing I wanted to mention is our very own project, Contour, another ingress controller built on top of Envoy, has hit version 0.13. This is on the march to 1.0. Dave Cheney is the main author here, but we have other folks from both Heptio VMware and the rest of the community getting involved here also. So super duper cool there. What I love is that there's a lot of folks from the community have started putting features into Contour, which I think is really cool. So it's good to see people go through and scratch their itch and make this stuff work. And then Nick Young just joined VMware, and he's helping out working on the project there also. So big news here is session affinity is supported, being able to have services with external names so that Contour essentially becomes a reflector at that point. Let's see a couple of deprecations and removals that some clarity on some stuff, HTTP, TCP idle timeouts, continue to see this in production and make sure that it's working well and that we're taking problems like memory leaks and such and really making sure we fix those. IPv6 improvements, so a lot of good stuff there to take a look at. So yeah, Lamati's saying Vault with Kubernetes. I think we did do an episode on Vault a while ago. I think Chris might have done it, but viewing it with that tool set may actually be interesting also. Okay, so that is let's see. So George posted this. This is, we did do this one. There we go. Yes, November 16th. But yeah. I'd love to go back and find the episodes that we should update and redo, because there's always new stuff going on, and it's like these things are, we live in a super fast moving world. All right, so let's see. So we're about 15 minutes in. All right, so I want to start talking about Velero and give a little bit of history behind Velero, and then we're going to sit and actually play with it and see if we can make it work for us. So Velero was a project that we started at Heptio, and at the time we called it Heptio Arc, as part of moving and rationalizing a bunch of stuff into VMware. It got renamed from Heptio Arc to Velero, so no VMware in front of it, just plain old Velero. And the goal of Velero is to be able to back up, migrate, and essentially clone applications and cluster data. Right? How do you actually sort of, in a principled way, look at what's going on inside of a cluster, be able to capture that, and then do interesting stuff with it? The interesting thing about Velero is it doesn't just capture application state. It also actually can go ahead and coordinate with the underlying cloud, the underlying infrastructure, if necessary, to be able to capture persistent volumes also. It's going to be interesting as we get first-class support of things like cloning and snapshotting in CSI exposed up through Kubernetes. I'm sure we're going to be looking to make sure that Velero can take the fullest advantage of those too. So Lamati's asking, why did we rename it? Arc was a killer name. Well, so here's the deal. So there was this other company out there that had a backup product aimed at consumers called Arc, ARQ, and there was a little bit of confusion there, but we were officially Heptio Arc versus ARQ, so the full name didn't conflict, and a slightly different target audience that we were going towards. But as we moved into VMware, VMware doesn't like to have things with VMware blah in front of the name for open source projects, and so we wanted to make sure that it was a name that could stand on its own. And so with that in mind, we thought it was probably best to be able to pick a new name and make it work. So that's why it got renamed to Velero. So Velero is a sailboat in Spanish. So we're keeping the nautical theme here at least. All right, so the original sort of idea behind Velero is early on, probably the first month that we formed Heptio. One of the things that we did is we're like, let's just start getting in the trenches with some potential customers, help them be successful with Kubernetes, and as we do that, we'll really understand what are the problems that they're facing. And so one of the first engagements that we did, they asked us, hey, how can I go through and they were using AWS, and make sure that when I create a volume via Kubernetes, it gets tagged in a certain way with using AWS tags. And so, the fascinating thing is that anytime somebody asks you for a feature, if it's not immediately obvious, you want to ask why. And so I asked them, I'm like, hey, so why do you want to actually tag, what's the scenario where you're tagging the underlying EBS volumes? Like, oh, we have this script that goes through and automatically takes snapshots of EBS volumes if they're tagged a certain way, and we want to make sure that our Kubernetes volumes are included with that. And that was like an aha moment, because we're like, nobody's looking at backup and disaster recovery for Kubernetes. This was probably 2.5 years ago, something like that. And so Arc / Velero started off as a EBS volume snapshotter. So essentially, how could we go through, start doing EBS volumes, but do it in a way that was sort of Kubernetes centric and was something that could could stretch out across just AWS. And over time, we looked at sort of the larger problem around disaster recovery and how we wanted to manage that, and that ended up turning into Velero over time. But Steve Chris, who's the lead on the project now, was the first author on this also. So he was there all the way from sort of the AWS snapshotter days when we were getting started off with this stuff. All right, so let's go ahead and start getting started. And if you hit documentation here, there's a where is it? Quick start with in-cluster Minio. Is that what we want? You know what? This is not what we want. Actually, I have it here. Set up Velero on your platform. Okay. So, so the way that Velero works is that it all works through CRDs. And so there's a server component that's a controller that operates with the CRDs, and then there's a client component to make it easier to be able to manipulate those CRDs. But as you'll see, as we start playing with this, those CRDs are perfectly accessible via the API and kube control also. It's just that the Velero UI just makes it a little bit of a smoother experience to be able to manipulate these things. And then you set up Velero so that it's actually hooked up to your cloud provider, so that it can actually then call through to actually make the snapshots happen. So you have to have some sort of access to the underlying let's see. So Lamati says that Chris Nova's talk on backing up and recovering across providers with Arc was amazing. Should we add that? Yeah, add that to the notes if you have a quick pointer to that. So yeah, so then Arc actually has to talk to the underlying snapshot provider, and then Arc also has to talk to a blob store, and that's where the actual configuration, essentially extracting all the YAML out of Kubernetes, gets written into that blob store. So this would be S3 and some underlying volume thing. But we actually view those two things as separate. So you could actually go through and write it out to some sort of object store someplace else. And so some of the sort of, if you want to play with this with Minikube, you can use this system called Minio, which provides an S3 work-alike type API locally. But it's also supported on top of AWS, Azure, and GCP. And then if you don't have access to the underlying volume snapshotting services, because not all environments have that, then it also supports this setup using this program called Restic. And Restic essentially scrapes the file system from the inside instead of operating from the outside with block devices. So that's how things work. So let's go ahead and get started on this. And I haven't done this in a while. We did one of these things for TGIK Live. But the first thing that we're going to do here is make sure that we get Velero installed. So brew, is it on brew? Do we have it on brew? Or do I have to download it and do it myself? Yeah, so okay, so we're already installed with Velero using Homebrew on the Mac. And upgrade to 1.0. Oh, this is like stuff if you want to upgrade from earlier versions. But okay, so yeah, so you can go through and okay, so a couple questions here. Yeah, there's a supported platforms link here. Where is supported platforms? Oh, there we go. This actually links through all the different things. So these are the ones that are built in, but also there's a way that you can actually go through and extend this with plugins, not something I mentioned yet. And so there's a whole bunch of plugins that you can go ahead and make work here. So it's great to see these things continually to be updated and have this be something that other folk can plug into. Does this work on-prem? So yeah, it can work on-prem. With Restic, you can scrape stuff from the inside. If you're using a SAN, you can either use or create a plugin for talking to your SAN to be able to drive this. Probably reach out to your vendor and ask them if it's something that makes sense for them to help out with, or if that's something that they support. And then where you put the backups, you can use something like Minio, or you can send it to S3 because you can access S3 when you're not running in AWS. So there's a lot of options there in terms of what might make sense if you actually want to take this on premises. Okay, so this is where we're at. Okay, so the first thing we're going to do is we're going to run Velero on AWS because that's what I have. You can get the official release of Velero here and put it in your path. You can also use Homebrew. I think that's what I'm using here. Oh, it's in user local bin. That's Homebrew. So the first thing we need to do is let's go through and we're going to create a bucket, and we're gonna actually. Okay, wait. I have two clusters here. Let's start with one. Bucket equals TGIK Velero 1. Okay, and then the region is, what am I in? I'm in Oregon, which is, why do they not say? US West 2. Okay. West 2. Okay. And then I have a simple kube control. I have a simple 2 nodes in a master cluster, so a small mini cluster running in AWS. And so the first thing we're going to do is we're going to create a bucket. What the location constraint region? Does that mean it doesn't actually leave that region? What is I don't know what that is. Does it actually talk about? What is location constraint and create bucket? I'm learning new stuff here. I'm confused. This is just make sure that stuff doesn't get replicated, I guess. I don't know. I've never seen the location restraint before. All right, I'm going to have to dig into that because I don't know. The region where the bucket resides, but that's actually, okay, well, maybe you got to do that because there's also region here. I'm a little bit confused, but let's just go ahead and create it. We're good. All right, so we now have a bucket called TGIK Velero-1 s3.amazonaws.com. All right, we're up and running there. And then, okay, so this is interesting. So we want Velero to be able to act as a user when it, when you actually use it, right? So this is creating the service account or the role, the IAM user that this thing is actually going to be acting as when it talks to my account. Yeah, so Nolan, I see that. I'm just like, I was confused because I would have thought that talking to the endpoint implies it, but you must have to actually sort of put it in the request also. Yeah. Okay, so now if you're running on AWS and you have something like kube.iam on it, that may be something that automatically works, but I think, in this case, creating a specific user for Velero probably makes sense. And so that's what the instructions here have you do. So we're going to go through and actually run this. So we're going to create a new user. Oh, I already had one. Oh, let me clean this up. I'm sorry, I didn't clean up everything. So we're going to go through and actually clean this up real quick so that I can make sure. So I have users, Velero, delete user, yes, delete it. And let me make sure that there's nothing else I need to, this policy. Yeah, okay. So we're good to go there. Okay. So we're going to go through this on the command line again. So this is one-time setup that you have to do for your AWS account. Once you actually got this stuff going, you should be good to go. Okay, so we have a user ID. We have a user named Velero. The next thing we're going to do is we're going to give it a policy. And this essentially is saying what this user is allowed to do. And it's allowed to muck with volumes, create and delete snapshots and all that. And then go ahead and do a bunch of S3 stuff, but only in this specific bucket. That's where this resource here is. And then we're also allowed to list what's going on in that bucket. So that's all good stuff. It's a relatively sane scoped policy. You might be able to scope it down even more. I think you might be able to give a tag constraint here, but I'm not sure. Okay, so we created that, and then we're going to actually put that policy on here. Does that work? Look at that. All right, so now the Velero user only has very scoped permissions. And now the next thing is that when you create a user by default, it doesn't get any sort of password. So I'm going to go through and do this. Actually, you know what I'm going to do is I'm going to switch just to my face so you can look at me while I do this, because I don't want to flash secrets up there. So let me go through. Let's see, I'm going to do AWS. Let me make sure. Secret key equals. Okay, I put those in some environment variables. So I should be able to go back to this. And hopefully I won't flash those on screen. And then what you can do is, let's see, and then we're going to create a credentials file in the local directory. And this is something that Velero install is going to use, and it's going to actually create a secret and upload that. So I'm now going to switch back, and I'm going to create the credentials file around that. So give me a second here. I apologize. All right, let me make sure that I get this. Sorry about this. So I'm creating, I have to bring up VS Code. Sorry. And we're creating a new file called credentials-velero. And then inside of that file, and this is like, so this is fascinating because AWS has a standard format for their credentials. And so this is being used both in the cloud, but also this is similar to what you would do if you actually were doing this locally to be able to act as that user. And I'm just doing a lot of copy and paste here. And it would be nice, I think it would be great, and this is the type of thing where the AWS command line tools are really sort of an API for Bash. They're not actually meant to be user, they're not meant for users. They're kind of meant for scripting. And so it would be great if, like, you know, when you create an access key, there was a way to say, hey, output that on your, all right, so output that in the right format here. Okay, so now I have one of these things, one of these files called credentials Velero, and now we're ready to actually install Velero. And so we're going to go through and paste this in. And so what this is actually doing is it's going through and creating the right YAML, putting the right sort of configs in there, and just installing Velero straight up. This is cool. It's installed. I think, you know, one of the things, and I don't know, is there a way, because I just did it and it did it. Okay, you can do like a dry run. So we could do with OYAML, and that actually gives us all the stuff that we're going to be doing. So, like, one of the things that that I would do is like I would like do this to velero.yaml, and then make sure that, you know, I'm totally cool with everything that's actually happening here as it goes ahead and creates it. And there you can see it's creating the secret and stuff. But it's pretty cool. I believe that there's like a Helm chart out there for Velero also, but this is an easy way to actually get the thing up and running. Yeah. Okay, so that's with the dry run and the -o YAML, which is the same as what you're going to get with kube control when you do this stuff. But roughly what we can see is, let's look at the resources that it created. It created a bunch of custom resource definitions, and we'll go through what a lot of these things end up being. It created a namespace for Velero. There's cluster role bindings, and so the cluster role binding, I believe, probably gives Velero pretty much carte blanche to do stuff in your cluster, because it is doing backup and restore. It pretty much has to be able to access everything. There's credentials for the cloud, and then it's setting up sort of the backup storage location and the volume snapshot location. So these are looking at, like, where do I want to put my config, and like where do I want to, in a cloud specific way, how do I want to manage snapshots? And then the actual Velero controller gets installed. So let's look at the one thing that I think is interesting here would be the role binding. Yeah, just cluster admin is what it gets, which is, it's doing full backup. It kind of needs full backup access. I know it's one of the things that the team have talked about but haven't done, is to provide a way to maybe have Velero act just within a specific namespace, but that's not something that I believe is supported right now. Okay, so we are good. Oh, and here's how you can actually use things like Kubernetes IAM, so you don't have to set up so that you're using roles instead of actually uploading a secret key like that. So that's actually pretty cool. All right, and so then if we go through and we look at getting started here, we can go through, and there's an example. Now this is the Minio. Let's see, am I looking at the right one? There's an example workload that we can actually get started with. And it's in the Velero source code. So this is one of those things, feedback for the Velero team, like, where is this examples, right? Do I have to git clone something? Is this something that's available elsewhere? I think it's, I do have to git clone Velero. And I think this was, and here's, oh, this was the other thing that I was like, hey, where's the GitHub link? Like, there should be a GitHub link right here. Make it easy to actually find the code. You guys are making it hard. I think it's still at Heptio Velero. There we go. Yeah, the release tarbles are in GitHub, but like, okay, so here we go. So yeah, so here's the actual code for the thing. Okay, so you're saying, oh, so examples are in the release tarball. Okay, which I didn't do because I used Brew, so I don't actually have the release tarball. But I can do a git clone of this, and I assume that this actually has examples also, the nginx app and stuff like that. Okay. All right, so the nginx app is like dead simple. I think there's one thing, like if we look here, so all this is doing is, if we could do kube control get storage classes. On Amazon, this one's called GP2. So what we got to do is we have to come in here, and we have to modify the with PV so that we can actually say, where to go, your storage class name here. All right, so let's go through sort of like what a minimally stateful app looks like that Velero is going to actually back up, because I think there's some interesting stuff that you see come out of this. Okay, so we have a namespace, which is nginx example. We have a persistent volume claim, which is essentially saying, please attach me, give me a persistent volume that I can work with. This is set up with auto provisioning, so it'll actually create the persistent volumes just in time for us to be able to use. I had to look up what the storage class name is. We're going to put that in there, and I'm saying I need this thing to be 50 megabytes, so nothing super big. And then here's something that's really interesting, is that anybody who's done backup knows that what you want to do is actually have your application as much as possible write all the data that it might have to disk, make sure that everything's in a consistent state, and then actually do the snapshot. And if you're doing stuff with EC2, it's up to you to coordinate sort of like, hey, database, make sure you actually flush all your buffers. Hey, file system, flush all your buffers. Okay, now do the snapshot. Okay, now go through and let things continue again. And so that's a dance that you have to do right to really do block level snapshots in something like EC2. And I think a lot of folks just go through and sort of do the snapshot, cross their fingers, and hope for the best. Velero actually helps to automate this. And so one of the things that you can do here is that you can tell it to actually run a command in one of your containers, both before and after it actually takes a backup. And so there's a pre and a post hook for this thing. And so what's happening here is that we're using the, a standard nginx container, but then we also want to be able to do an fs freeze, which essentially says flush the buffers and freeze the file system. And so that is actually running in a sidecar container, which exists solely so that we can actually run these hooks in it as necessary. And then Velero will take care of actually making sure that the hooks are actually called so that you can do whatever application specific things you need to do to be able to get yourself ready to snapshot. And so in this case, it'll call fs freeze with the freeze parameter, take the snapshot, and then after the snapshot has returned, it'll actually unfreeze it. And so this is a really, really cool feature that it actually takes care of making sure that everything has quiesced and you've written everything down. And so that's done with annotations on the deployment. And then, let's see, these are annotations on the pod that actually get passed through from the deployment. And then there's an extra image being run just so that it's around to be able to do that. And you'll see that this is running as a privileged thing to be able to do the snapshot. Hopefully over time we'll be able to make these things be less privileged. And then there's a service with type equals load balancer to be able to get at this thing. So if we do kube control, we want to do cube namespace, and we're in the nginx example namespace. Cube, oh wait. Oh, we haven't applied it. Ha! Cube control. Undo. I'm going to try using cap from last time. Use it for real. Deploy. Oh, we have to do -f. Oh. All right, so yeah, those are the things that we're doing. Go ahead and do this, and I'll go through, and there we go. Oh, the bottom of my terminal's cut off. There we go, sorry about that. Okay, so this is taking a little bit longer because it actually has to create the EBS volume behind the scenes there. Hopefully it'll work. This worked a little while ago. There we go. Okay. So now if we do cube control get PVs, VVCs. Oh. Okay, so there's the PV. It's bound. Cube control. Oh, cube NS. We're doing that. Cube control get PVC. It's bound. Cube control get pod. We're all up and running. Cube control get service. And here's my ELB. And it's not totally up yet, but we can do, let's see, it's port 80. Cube control, port forward, service. And my nginx 80. Does that work? So now if I go through and I do localhost 8080, welcome to nginx. All right, thank you for using nginx. All right, not very exciting, but there you go. That's what it is. Okay, so but that nginx is actually coming from that nginx is actually coming from the serving data from the persistent volume, right? So if we go through and let's look back here at our YAML, what we can see is this is being mounted into var log nginx. Oh, actually, no, it's actually writing log data to that. So now if I go through and if I do kube control exec -ti and where's the pod? Oh, there it is. Okay. Kube control exec -ti. Does that work? Wait, exec. Oh, bash. There we are. Okay. So now if we do user cat var log nginx, so you can see our access log here is not getting lost. So Shahar's like, why do you usually port forward instead of going to the load balancer IP? The load balancer hadn't actually initialized yet. It takes Amazon quite a while to be able to actually get its act together and get the load balancer configured. And so I'm moving too fast for it. It's probably actually up and working now. Okay, so you can see that like now we actually have this up and running. Like if we do the load, if we do the service, let me copy this. Let's see if this is actually up and running now. Okay, yeah, so now it's up and running through the load balancer. I love K9s for debug and accessing pods in Kubernetes. I haven't played with K9s. I'll take a note of it. I don't think I've used that one yet. We have some other fun stuff coming sometime soon, which is going to be super cool for this too. Okay, so now I can go ahead and I can hit this. If I go through and if I exec back, actually what I'm going to do is I'm going to not exec back, I'm going to exec with cached var log nginx access .log. Is that what it's called? Yeah. So there, boom, we got that going. Okay, so we can look at it. We see stuff that's coming in, looking good. Yeah, so that's super cool. Okay, so now we have that up, like, but you know, it's like, hey, if my pod dies, I want to make sure, you know, that access log doesn't get lost. And that access log could be a database, it could be other files, you know, there could be all sorts of different things. So this is just a super simple thing to actually look at here. So now what we're going to do is we're going to actually take a backup of this. And so when we run, so Velero backup create, so we're creating a backup called nginx backup, and we're making sure that we include the namespace nginx example. And so this thing says, okay, you know, the backup request has been submitted successfully. And so now what we can do is we can go through and we can do a describe of that backup. And here's a bunch of information that we have about it. So it's and this is using the Velero command. It's called nginx backup. It has some labels in it in terms of where the storage location and stuff like that is. It says completed, so there's a phase that's going on here. Which namespaces are included, excluded, so the parameters coming in. And then there's a TTL on here of 720 hours. So these things will automatically get deleted after a certain amount of time. And then there's information about how long it took. So it took us 2 seconds to actually take the backup. Relatively quick, super quick. All right, so what happened in those 2 seconds while we were taking this backup? Okay, so here's what happened. Velero on the server side talked to the API server, did a walk of all the resources in the cluster, captured those things. I think actually it did a walk of the resources for the application, plus any cluster level resources that it needed, captured those things, put them into a tarball, uploaded that tarball to S3. While it was doing that, it also found that we were using this PVC, this persistent volume, this EBS volume behind the scenes. It did an exec into the workload, into the nginx, did the FS freeze, told EBS to take a snapshot, and then after that snapshot was done, it then actually called FS freeze to unfreeze the file system. So that's the stuff that went on here. And if we start looking in the AWS console, we'll start seeing some evidence of what happened. So the first thing we can do is we can look at snapshots. And oh look, we have a snapshot here called Kubernetes dynamic PVC, blah, 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 some random number. But you can see that there's information here in tags in AWS talking about sort of like, which cluster, which PVC name, what the PVC name, the namespace of the thing, which backup this is part of, which PV this was actually related to. So it keeps all the breadcrumbs necessary to be able to relate this back to the actual PV that was created in Kubernetes. And then furthermore, if we go through, and I don't think I have S3 pinned up there, but if I go in and start looking at S3, you can see that here we have Velero, and one of the things, and it actually has its own file structure inside of S3. And here we have nginx backup, and there's information here. There's essentially the a metadata file along with the backup, the log file, and then metadata around the snapshots that were taken there. And so all of this stuff is actually stored into S3, and then there's metadata also about sort of like the revision of the directory schema and stuff like that. So it's also worthwhile, I think, to dig into this. So let's take a look at this particular file here. And we can do an object URL here. And I'm going to hit download, and that's going to download it here. Explode. I don't know. And then so let's untar this. Let's see. VVF. Okay, and then Steve says you can also use Velero backup download to actually get the tar ball as well. And so here's what we can see is that it actually exploded, and there's a directory structure here that mirrors a bunch of the stuff that you'll see inside of the Kubernetes cluster that you're backing up. So if we look at explode, there's metadata, which is like version of the file of the schema, and then resources here. For each resource, let's see, we can do. It grabs the resources that we actually grabbed. So here's like in this namespace, there's cluster information, persistent volume claims, and stuff like this. So I can actually then go through, look at my deployments, and here's the nginx deployment saved as a JSON file. And so one of the really nice things here is that Velero is great to do stuff automatically, but if you do need to actually sort of dig out sort of like the raw data of what you were running, it has a useful, like you can actually explode, inspect, see all the information that it's backing up also. All right, so so we took a backup. We dug into sort of what that backup looks like under the covers. And so now let's go through and like say, okay, something bad happened, and we're going to go through and delete that namespace. And as we delete that namespace, it'll take down our load balancer. It'll take down the all of the PVs that we created and stuff like that. So if we look at volumes here, I think we have. So we have a dynamic one. It takes a little while to actually go ahead and delete this, but let's give it a second here. And this could be either deleting the namespace, or it could be deleting the cluster as a whole. So we can actually, we'll see how we can move this stuff cross-cluster too. So this thing is now deleted, and I believe if we do like a refresh here, okay, it may take a while, I think, it's no longer attached. It may take a while for Kubernetes to actually garbage collect this and delete it. But what I'm going to do here, kube control, list PVs, or get. Is it gone? Yeah, okay, so it got its act together. Now that PV is totally gone. And so now we can actually go through and do a restore from backup. And so you create a restore request saying which backup you want to restore. And so it gives it an automatic name based on the date and time. And you can see that at this point, uh-oh. nginx deployment, blah, 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 already exists and is different from... I'm very confused on what happened here. Or maybe... Oh, I see what happened here. Is that it was trying to create the namespace, the deployment, and there was a race between the deployment object creating the replica set and Velero recreating the replica set. So there's some, it captures a lot of raw information, but Kubernetes is resilient enough that this does actually go ahead and settle down. And so now we actually have this thing up and running again. If I go through and get pods, I have this pod here. If I do exec, is it named? Oh man, it actually has the exact same name. If I go through and look at this, you'll see that we haven't hit it again, but the logs are still there. So it actually round-tripped this thing through a snapshot and back to be able to make this happen, which is really, really cool. So yeah, so there we go. We went through that. Now, interesting thing. So like that's sort of the main flow. Couple of things that I think are worth looking at here is you can set up a backup schedule. Okay, Shahar's asking, does Velero let you restore from one cloud provider to another? The answer is kind of. If you're not doing persistent volumes, then you can go ahead and actually move things from one cloud to another, no problem. Moving something like an EBS snapshot is trickier, right? So, I mean, theoretically, and I think this is something that we've talked about, but it hasn't happened yet. It would be possible to have sort of some background workers that if you did want to move something from one cloud to another, you could take a snapshot, reconstitute that into EBS volume, mount it onto a VM someplace, use that VM to scrape what's going on inside of that volume, then upload that to something like S3, use that to move things from one cloud to another, and then reverse the process to create a volume on the other side. I think it's a workflow that's doable, just nobody's done it quite yet to be able to automate that type of movement. But it's definitely on our radar. If you're doing something like Restic, which is the alternate sort of non-block-based but file-based thing, and this is what Nolan's saying, you can go through and actually use Restic to scrape things from the inside of the VM and then restore into the inside. And so you're not actually getting point-in-time block-level snapshots, but those things will fundamentally be a lot more portable than if you were trying to do the block-level snapshots. All right, so that's where we go. So so things that I want to do yet is let's go through and set up a backup schedule, and then also make sure that we can go through and restore onto a different cluster, because I think that ends up being super interesting also. So the schedule is actually super easy. And then Nolan says we also don't do storage class translation, which is tricky too. One of the interesting things though is that I think another thing that you could do either built into Velero or separately is you can take that tarball that describes all that stuff and you could filter, mutate, change that as you're actually moving stuff around. And so getting to the point where we think about like how do we want to actually take that tarball, perhaps manipulate it, ends up being an interesting thing. Okay, let's go ahead and, before we create the schedule, there's one other point that I want to make, and this is actually pretty fascinating. If we do kube control Velero get backups, what we can see is we're using kube control to get this thing as we actually see the backup. And then if we go through and if we like copy this get backup, the YAML for this thing is relatively simple. It's just metadata. And then I think the fascinating thing here is that it's actually pointing to the, let's see, it's pointing to the storage location where this thing is stored based on the name. And so the canonical sort of like the sort of place of record for what snapshots you have is actually S3. So if I go through, and it may take a little while, so I'm a little off script here, but if I go through and if I delete this thing, if I delete this backup, now this just deleted that record that's sitting in my Kubernetes cluster. It hasn't actually caused the thing in the S3 bucket to be deleted. And so now if I go through and get backups, kube control and Velero get backup, it doesn't find any resources. But what actually happens, and I think it takes a while for things to resync, is that Velero will actually go through, list the contents of S3, and then repopulate the Kubernetes resources based on that. And perhaps somebody on the team knows if there's a way to actually go ahead and kick it and make it do it. I can probably just kill the pod and it'll actually do it. Kube control, dash N, okay, kube control. So if I actually cause Velero to restart, I think it does a resync to S3. It takes a little while, but yeah. But now as it comes back up, now if I go through and do get backup, maybe. All right, you're making me look bad, Velero. So Steve's saying it takes a little while here, so we'll see. All right, we'll come back to that in a little bit and actually make sure that it's working. All right, so let's go through and actually create the backup schedule. So this is so a schedule is another type of CRD, another type of object. Okay, so Thomas is saying that researched this last week, no way to jumpstart the resync. It defaults to every 60 seconds. So it'll take a little while. It's eventually consistent to some definition of eventually. And so here's what we're saying. So we're creating a schedule and we're going to call it, TGIK backup. And then the schedule uses like general sort of cron tab format, right? And so I always forget these things, but it ends up being minute, hour, day of the month, day of the week. So this is saying I want to create a backup at 7 a.m. every day in UTC, I believe. That's what we're actually saying here. But what we want to do is we can say I want to take a backup every 5 minutes. And I think that'll work. Now, the tricky thing here is that at some point you hit a quota in terms of the number of EBS volume snapshots you can actually create. But we'll just go ahead and let this thing do its thing. So now we do kube control get or Velero get backups. And here you can see it went through and created the backup there. We still haven't synced that other backup, so I don't know what's going on here. But if we go, yeah, this just happened now. Did it actually go through and delete it from S3? That would be crazy. Did I hit the wrong command and actually really delete the backup? Let's go back to S3 and see what we got going on here. Backups, yeah, so there's nginx backup and TGIK backup. So it should eventually get its act together and actually get this thing. There it is, okay. So yeah, so now we actually see here we have both the nginx backup and the TGIK backup. And so this is really demonstrating that the S3 bucket here is the source of truth. Velero is just actually reflecting the status of that S3 bucket into into Kubernetes as a CRD. And now this will actually go through and actually create a snapshot every 5 minutes, which is pretty cool. All right, so the next thing that we want to do, and I think this is the last sort of the basic stuff, is how do I actually go through and do cluster migration, actually recreate this application on a different cluster altogether. So to do that, what we're going to have to do is I have another cluster here, kube control, get nodes, kube control, get namespaces, and you'll see that Velero is not installed here. So I want to do bucket equal, okay, so we're going to actually set the bucket equal to the same thing. And then we have region equals, so we need region and bucket to install Velero. And we have we already have the bucket created, we have the user created, so all those things are the same. Now I can just go through and install Velero. I have the credentials there. So now we're installing Velero in this new place. Now, the interesting thing here is that we have two of these things pointing at the same bucket and the same place in the bucket. And generally that's bad. That's not something that you want to do. And so if we go to the instructions here, one of the things that they're doing is that they're saying in cluster 2, which is TGIK 2, you want to actually start setting a restore only flag, which puts Velero into a read-only mode. Now this is for Velero 1.0. There's a feature that's in GitHub right now that's in the master branch that hasn't been put into a release yet, where you can actually set particular backup locations to be read-only. And so that way, like if you're doing a disaster recovery, you can have your previous set of backups be read-only. But then you as you bring that thing back up, you can start taking new backups into a new bucket, into a new location. And so I think that's going to be nice to actually have Velero operate as read-only via some backup locations, but read-write with other backup locations. This is not absolutely critical, but we're going to go through and actually set this here. So I'm going to do kube control, edit, deployment, Velero, and if I go here, what you can see is, where is it? We have the container, the server container. Is there an args here? There's no args. Arg. Oh, arg. Okay, so we're passing a, okay, so we can do, there we go, restore only. So we're now actually setting that. That'll actually go through, it'll restart Velero, and now it's in that read-only mode. Dimitri says, would be nice if Velero install would print out the config to standard out for piping to other tools similar to linker deinstall. Which config? Oh, the config that essentially the YAML that it created, or what were you thinking, Dimitri? So you can do the dry run YAML, yeah. Okay, so now this is actually fascinating. We've seen that it's already synced up. This one happened faster from the other one. So here, Velero get backups. You can see we have 3 backups here. We have the backups that are sitting over here also. So now we see both of these backups on both clusters, and now we can actually choose the latest one here and do a Velero restore, right? Okay, restore, create from backup, and then we can actually name the backup that we got here. And we can go do a describe. It's in progress. Let's make it work. I don't know, hopefully we didn't hit a quota someplace. Okay, so kube control get namespaces. Okay, so we have the nginx example namespace there. Kube control kubernetes nginx example. Kube control get pods. The pod's running. Okay, so it restored everything across the cluster, and you can see that it's like, oh, some of these things already existed because it's like did some calico. So you can also scope the restore just to a particular namespace, which is something that we could have done before. And so, yeah, so I think there's a certain amount of like, if you're doing a restore, it captures all the information. Some of it may be stuff that's applicable, may not be. Like, let's say you're using Calico on one cluster and you're using, sort of the native AWS CNI stuff on another cluster. It'll copy the Calico configuration over, even if maybe you don't want it to. And so this is one of those things where, over time we're going to have more flexible filtering in terms of the types of objects that you want to be able to restore, and which namespaces. And I think there's room for, creating a sort of more visual way of actually looking at what's in a snapshot or what's in a backup and what's working and what's not working there. But what we have now is I've essentially moved this nginx thing from one cluster to another cluster, and now I am in cluster 2 here, and I can do kube control exec, kube control get pods, kube control exec, dash, oh, I have to do dash n nginx example. Use kube control, wait, what am I doing wrong? Not n. All containers. Yeah, dash, do I have to get a dash IT? Yeah, okay. Does that actually work? Okay, there we go. The var and you can see that, the access log that we had that we started out with is still here. So we both deleted and restored it on the first cluster, and then we essentially cloned that entire application over to another cluster. So that is really cool. And so there you go. You can do and you can see here's the status of the backup, the restore. And if we do Velero get backups, you can see that it continues to take snapshots, backups every 5 minutes here. All right, so that is the main flow of Velero. That's the stuff that I really wanted to show off. I think it's worth talking about some of the stuff that's actually coming down the pike in terms of things that we're looking at. So the first one is that there is native snapshot support being pushed as part of Kubernetes. This is a lot of work happening in SIG storage, and Velero's working that it can actually sort of operate and work with that snapshot. I think we're still figuring out sort of, are there things that you can do with the native capability versus the built-in capability. There's a lot of interesting work going on there to figure out the best use of that. I know Nolan, who's on the chat here, has been working hard on that. There's the read-only read-only backup locations for doing restores. That's another thing that we're working on. Steve, Nolan, is there any other sort of up-and-coming features that that you all are working on? I mean, obviously there's plugins, and so we're working with a lot of folks to make sure that we get as many plugins as possible. I know that there's a lot of talk about sort of getting something going with the vSAN folks here at VMware so that they can actually be well supported here too. Okay, so working on moving the Restic integration to GA. It's currently beta. So Restic is a little bit more complicated because you actually have to, you don't have this sort of like, hey, just make an API call and it creates a clone of your disk. It actually has to do some relatively interesting stuff from the inside. How is Velero working with Helm? Helm has its own sort of set of state, and I believe Velero will back up all of that state also. As with Helm 3 moves to something that's much more CRD based, I think that'll actually work a lot better with things like Velero. Oh, and then Steve's saying we're also thinking about the idea of delegated backups, so individual namespace owners can back up and restore just their namespace. I think that'd be a really, really cool feature. That's the first I've heard of that. That seems really cool. Steve or Nolan, do you have any comments on the interactions with Helm? So there's a Helm chart to deploy it. In terms of intelligence around Helm resources, we're not quite there. Probably need some action plugins. So yeah. I mean, Helm is not just, it's more stateful than I think it probably needs to be. I mean, some of that is just point in time of when Helm was created and such. So yeah, so with that, I'm going to call it for today's TGIK. Thank you, everybody, for taking the time to hang out with me. Please, 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 submit ideas into the TGIK repo. We've switched to the new channel here. This is the new VMware Cloud Native Apps channel. If you haven't already, please subscribe there. I think most of the new content coming out there is really going to be Kubernetes, upstream related stuff, whether it be we do office hours for Contour and Velero and stuff like that. Let's see. Also, one other thing that I want to mention is that next week on Friday, and I'll tweet about this also when we get more details, is that we're going to be holding a Cloud Native Happy Hour, which is something that Nicholas Lane, one of the Kubernetes architects, field engineers that we have here, does, where get together and it's a much more in-depth sort of like let's explore the new features of the Kubernetes version. He kind of runs it as a show and tell type of thing versus me doing my own thing up here. And so that's something to take a look at next week. Stay tuned for more details there. So with that, thank you, everybody. Thanks for joining me. And I don't think I'm going to be doing TGIK next week. I have a conflict, but we're working on finding somebody else to take it over for the next week. And I will see you all later. All right. Thank you.